What we are going to do here is I'm going to run you through the process of some of the calculations for ANOVA and creating our ANOVA table. So before we create our ANOVA table, there are several things that we need to do. So let's say that we have the raw data here. So here are the raw data, right? So we're looking at the data. So this is the voltage, right? So this is the extent to which the teachers applied various levels of voltage, right? So here, case number one, the white male, when the authority was the white male. So let's just put that up here. So authority figure, right? So when the authority figure was the white male, the teacher applied 100 volts. When he was the black male, the teacher applied 254, so on and so forth, right? So these are the raw data. So there are several things that we need to do before we start creating our ANOVA table or our F table. The first thing we need to do is with our raw data here, as you see our raw data, we need to first start by squaring every single one of our cases, right? So let's start by doing that here. And so right here we have this xi. Xi represents the raw score for each individual. And here we have x squared over, x squared sub I. And x squared sub I is the x's squared for each individual, right? So let's just go ahead and do that real quick. So I'm doing this in Excel just to kind of demonstrate. You can do this by hand if you'd like. I prefer Excel. And I think it's just kind of easier and quicker to demonstrate here. So what we're doing is we're doing x squared, right? So x times itself is x squared, and we'll go ahead and do that. So as you can see, 100 times 100 is 1,000, and we'll bring that all the way down, right? So that just copy and pasted the entire formula all the way down. Right, so now for the white, when the authority is the white male, the voltage is now squared for each one. So we have that. Let's do the same thing for when the authority is the black male. So you can also do power of, so if you want to do like a power of 3, for example, or cubed, whatever, you can do that as well. There's a function in Excel to do it. I was going to see if squared was a function, and it's not. So we'll just go ahead and times the number by itself. That's easier. So again, 254 times 254. You can go ahead and press enter, and we get our squared number there. Okay, and then we bring it all the way down, do the same thing. And just a quick note, if you are using Excel, you can do the same thing. And so Excel is relational, and what that means is when I have this function in here, if I copy it, it won't copy that function specifically. What it does is it's being relational to the cell next to it. So I can actually copy this and then paste it here, and you'll see it right there. So it's relational, right? It's picking up the thing next to it. So since I don't want to mess up my colors, I'm going to do this by itself, right? So again, 200 times 200. Bring it all the way down, and then here we go here, 400 times 400. Do the same thing here, bring that all the way down. There we go. Now we have our raw scores, and then we have our raw score squared, right? So you should have 40 of each of those. Now what we need to do is we need to sum those scores, right? So we have our sum of the raw scores and then sum of our raw scores squared, or in other words, the sum of squares, right? So how to do this is there is an easy function in Excel. So basically what we're doing here is we're taking all of these scores and we're adding them together. So we're not taking an average here. What we're doing is we're actually adding them all together. So to do that, we are summing them, right? So we can use the sum function in Excel and just go ahead and highlight all of those, close your parentheses, press equal, or excuse me, press enter, and it'll go ahead and do that. So let's do that for all of them. Equals sum. Right, so we're doing that for all the raw scores, not the squared scores. We won't do that yet. We'll put that into a different row. So sum, down. There we go. Okay. So we have an interesting thing there. So then what we do is we do the same thing for the squared scores. So this is the sum of squared scores, right? So we'll go ahead and do that. So the second column is the squared scores, and we'll go ahead and sum all of these up. Right, so we'll just go ahead and do that. And so just to make this quicker, I'm going to copy and paste this formula. So again, as you can see, right, it's being relational, so it's just following it down the line. Do that here, do that there, right? And this one is possibly too large, so we'll go ahead and open it up. And so this looks like it accidentally copied my little formula here, so I'm going to remove those so you can see what they are. Okay, so now you can see all the raw scores, right? So now we have the raw scores squared, the sum scores squared. Now we need to take the average of each group, right? So when you see this little K, that means group. So K in ANOVA always represents the group. So now we're taking the mean of each group. So in Excel, for some reason, Excel's function has mean and median, but it doesn't have, it has median and mode, but it doesn't have mean. In Excel, mean is average, right? So we'll use the average here, and we'll do the same thing, right? So we'll copy that. And so now we have the average of all of those scores. So what this is telling us is that when the authority figure is a white male, on average, the teachers will shock up to 263 volts. On average, right? 263.8 volts. So that's the average voltage, right? So we're taking the average of each group. And so we'll bring that across, and we can see that for each one. And now we will take our overall average, right, or our overall mean. And so this is the mean for all the groups across the whole sample, right? Not just within each group, it's for all of the groups. So we'll do the average function in Excel, and then this one's going to be a little more difficult because we have this, and then we have this, then we have this, and then this is our last, right? So this is going to take the average of all the scores. So this is all 40 raw scores, right? So we have an N of 10 for each group, and so a sample size of 10 for each group, and this will take the average across all 40 individuals. And so on average, right, on average across all different authority figures, people will shock up to 244.175 volts on average, right? So this is what we're going to do, and so you need this data. So, and particularly, you're going to be using this data right down here, right? So you'll be using all of these data to help complete your ANOVA table. So it's really important to have this stuff and to do it correctly. So again, Excel is just faster and a little easier, and obviously more precise. So it's important to also know how to do this stuff by hand, but these are fairly simple. They're fairly straightforward equations. There's a lot of them. That's all there is. So again, we have our squared score. We have our scores, our raw scores squared. Then the sum of our raw scores, the sum of our squared scores, the average within group, and then the average across all groups, right? Or the mean within group and the mean across all groups. So that's what we need here.